Hello everybody. This video is going to go over the kinetic and potential energy worksheet that's in your packet. If you're looking at this paper, you can see that we have two different formulas we might be using. One of the formulas is for kinetic energy. Remember, kinetic energy is the energy of a moving object. So we're going to use this formula anytime something is moving. Kinetic energy equals 1/2 times mass times velocity, and the velocity is squared. Only the velocity is squared. If we have something that's high up off the ground, it doesn't have to be very high, but it is up off the ground, then we're going to be finding the gravitational potential energy of that object. Gravitational potential energy is mass times gravity times height. Now, something to stop and think about. We talked really briefly earlier in the semester that weight is a force, and the weight of force, force as weight, is found by multiplying mass times gravity. So when you're trying to find potential energy, if you have mass and height, you multiply those times gravity. But you might also have a problem that gives you the weight or force in newtons. And in that case, force is equal times mass times gravity. And then you still just need to multiply by the height. So let's take a look at some of these problems. So I'm looking at number 1. You serve a volleyball with a mass of 2.1 kilograms. For anybody who doesn't play volleyball, that means you hit the volleyball, so you're making it move. The volleyball has a mass of 2.1 grams. The ball leaves your hand with a speed of 30 meters per second. The ball has blank energy. Is it moving? If it's moving, you're going to use kinetic energy. Otherwise, you're going to calculate potential energy. Then you need to calculate the kind of energy that you chose. So in this particular example, we have a mass that is 2.1 kilograms, and we have a speed or velocity of 30 meters per second. Well, hopefully it's pretty easy for you to see we're going to be calculating kinetic energy in this case. So the ball has kinetic energy, and in order to calculate it, I have my mass, my velocity. I'm just going to substitute those values into my formula, and that's how you're going to solve the problem. My daughter has my calculator right now because she's doing her math homework in another room. So I'm not going to go through and work that one out, but I will set it up for you. So kinetic energy is equal to 1/2 times 2.1 times 30 squared. If you have a calculator, if you know how to put in the fractions 1/2, you can go ahead and do that. My calculator doesn't do fractions. I have a really basic calculator. Instead of multiplying by 1/2, you can multiply by 0.5. That means the same thing. Okay, so that's how you can do that if your calculator doesn't do fractions. Remember, the 30 is squared, nothing else is. All right, I'm going to look at problem number 2. And problem number 2 says, a baby carriage is sitting at the top of a hill that is 21 meters high. The carriage with the baby weighs 12 newtons. The carriage has blank energy. Calculate it. All right, just like before, step 1. Is it moving? No, they haven't said anything about moving. So we can't do kinetic energy. It's on a hill, and they told us how high the hill is. So that means we're going to be calculating potential energy. In order to do potential energy, we need mass times height, and we already know gravity. Or we need force times height. Let's go through and look at that problem again, okay? They told us the hill is 21 meters high. Well, that's a height, 21 meters. Then they told us the carriage with the baby weighs 12 newtons. Weight is a force. And again, we know that's a force because they gave it to us with the unit of newtons. So we have force equals 12 newtons. Potential energy due to gravity is force times height. So we are going to have 12 times 21, and that's how you're going to calculate that problem. Pretty much everything on this paper is going to work out the same way. If you have any questions, please feel free to text me on Remind. Thanks, guys.